Drop past the sunlit surface, down beyond the twilight zone, and you enter the bathypelagic. Between 1,300 and 2,000 meters deep, the ocean becomes a lightless void. The pressure here is crushing, and food is almost non-existent. Looking at this preserved specimen of Mitsucrina austoni, or the goblin shark, it looks like a creature built out of spare parts. It has a soft, flabby body, tiny, almost useless eyes, and a massive trowel-shaped snout protruding awkwardly from its skull. To human eyes, accustomed to the sleek, muscular profiles of coastal predators, this animal seems like an evolutionary mistake. Its weak musculature and floppy fins suggest a sluggish swimmer incapable of chasing down a meal. Yet this exact model of shark has been swimming in our oceans for 125 million years. This museum cast shows the distinct profile of a species that existed alongside the dinosaurs and outlived them, earning it the title of a living fossil. Dominating one of the most unforgiving environments on Earth for over 100 million years requires extreme specialization. The goblin shark relies on a series of radical design trade-offs that have remained unchanged since the time of the dinosaurs. In the deep sea, the ability to conserve energy determines who survives. When a single meal might have to last for months, maintaining dense muscle and high swim speeds is a massive waste of calories. The shark's apparent weaknesses are actually highly efficient energy-saving measures. This infographic illustrates how light behaves underwater. The goblin shark's translucent skin exposes its pink, oxygenated blood vessels. Because red light is absorbed in the first few meters, a pink animal appears perfectly black in the deep, rendering it invisible to surrounding creatures. Inside its soft body, a massive oil-filled liver makes up a quarter of its entire weight. Because sharks lack swim bladders, this oversized organ acts as an internal flotation device, allowing the goblin shark to hover in the water column with neutral buoyancy. It can drift like a ghost without twitching a single muscle. But hovering invisibly only keeps you alive if you can actually locate a meal. In a zone with zero sunlight, eyes are effectively useless for tracking prey. That is where its bizarre blade-like snout comes into play. The underside of this enormous rostrum is packed with hundreds of tiny jelly-filled pores, known as the ampullae of Lorenzini. These organs function as a biological radar system. They are incredibly sensitive electroreceptors, detecting faint, rhythmic electrical pulses of a crab's muscle contraction or a squid's beating heart, hidden in the pitch-black dark. The goblin shark trades muscular power for sensory precision and camouflage, allowing it to own the midnight zone. Finding prey is only half the battle. Because the goblin shark is too flabby to give chase, it needs a way to close the distance the instant a target drifts within range. It solves this with a mechanism called slingshot feeding. Tucked flush against the underside of its skull, the shark's jaws are held under extreme tension by two pairs of elastic ligaments, ready to snap at a moment's notice. Based on high-speed footage captured in Japan, we can see exactly how this works. During the expansive phase, the shark lifts its head. Then, in the compression phase, it releases the tension in those ligaments, catapulting the jaw forward. The lower jaw launches at 3.14 meters per second, reaching out 10% of the shark's body length. This violent forward motion forces the throat to expand instantly. The sudden increase in volume creates a powerful vacuum inside the mouth, a process known as pharyngean suction, that pulls the water and the prey directly into the shark's throat. The jaws are lined with rows of long, needle-like teeth. These slender fangs are shaped specifically to snag and hold the soft, slippery bodies of deep-sea squid and rat-tail fish. The slingshot jaw allows a sluggish predator to execute a hyper-fast strike. Without accelerating its whole body, it simply shoots its mouth at the target. The goblin shark is not an incomplete draft of a better predator. It achieved biological perfection for its specific environment 125 million years ago and has seen no need to change since. Look at this great white shark, a modern cousin in the mackerel shark order. It took a completely different evolutionary path, developing high-density muscle and a streamlined shape for high-speed chases in the sunlit waters above. This image displays a collection of ancient teeth belonging to extinct relatives of the goblin shark. The goblin shark branched off near the very base of its family tree. Its genome evolves at an incredibly slow rate, leading it as the lone survivor of an ancient lineage whose other relatives went extinct millions of years ago. By retreating into the freezing, lightless, and highly stable conditions of the ocean's basement, this specific lineage bypassed the catastrophic surface events that wiped out the dinosaurs. Far out of sight, in the crushing depths of the midnight zone, the goblin shark continues its silent patrol. It remains a master of the abyss, utilizing a survival strategy so effective that it has remained viable for 125 million